If you would like to follow along with what I'm going to be talking about here, you can turn to page 16 in your packet. Several of the examples I'm going to work are out there, maybe in a different order, but I am going to work some of those, and it also has a recap of the directions of how to approach this type of problem. Okay, so the next type of reaction we're going to be talking about is a single displacement reaction. Single displacement. And you also may see this called a single replacement sometimes. Okay, so what happens in a single displacement reaction is we start out with an element and a compound. So we have a compound, usually it's in an aqueous solution, and we're going to add some element to it and see what happens. So we start out with a compound. And we add an element to it, and we get a compound and an element again. So it'll come out, let's say, element plus compound. Okay, so we start out with a compound and an element, and we end up with an element and a compound. So that doesn't really sound at first glance like anything's really happening, but let's take a look at an example here to actually get a concrete grasp on what could really happen. So if you look on your periodic table, we're going to need this to be able to do these type of reactions. We have this chart on the back here. It's called the activity chart. So if you notice on the activity chart, some of these elements are higher up than others. This activity chart is basically saying how much these elements want to react. So the elements at the top of this activity chart are the ones that really want to be in a compound. They're really reactive. They don't want to be by themselves. They want to be with something else. Whereas the elements down at the bottom of this activity chart here don't really care if they're with someone else or not, so given the opportunity they'll be by themselves, whereas the ones up at the top of this chart are going to want to be in a compound if they have any possible opportunity. So you'll notice there's a different column here for metals than there is for nonmetals, because only a metal can replace a metal and only a nonmetal can replace a nonmetal, so they're kept track of separately. But we will come back to that in a second here to see how that works. So let's say we have a reaction here where we have lithium, and let's add it to calcium chloride. So lithium is our element. This comes in its elemental form, so this is usually going to be a solid that we add in. And our compound here we're usually going to have is an aqueous solution. This doesn't necessarily have to be the case, but this is how we're going to see it the vast majority of the time, since that makes it easy for us to look at. So we have our element, we have our compound. So now what we're going to do is compare to see if this lithium wants to be in this compound more than the calcium does. So since lithium is a cation, we're going to compare it to other cations, so therefore it's going to be compared to the calcium, not the chlorine. And we're going to see if this lithium can knock this calcium out of place and take its spot. So to do that, we're going to look at the activity chart here, and we're going to find calcium and we're going to find lithium. So looking down here, I see calcium. Okay, there's calcium. Now let's see how that compares to lithium. Oh, lithium's at the very top. So since lithium is higher on this activity list, that means that lithium is going to knock the calcium and steal its place. So let's go over here. In order to see what our products are going to be, we're going to have to think ions when we do this. So this calcium is going to get knocked out, and it's going to be by itself then. So we're going to end up with calcium as a metal. And in this compound then, this lithium is going to have not the charge that the calcium had, but the charge that a lithium would have. So we know that lithium is in the alkali metals group, so lithium is going to need to have a charge of +1 on it. So we put lithium and chlorine together, and because lithium has a +1 and calcium has a -1 charge, those are going to cancel each other out, and we have a 1-to-1 ratio. So our products are calcium and lithium chloride. Now, of course, we'd have to go back and balance at this point, so we see that we have 2 chlorines there, so we need 2 of these, and that'll give us 2 lithiums so we can balance, and now we're good there. So we started out with lithium, we added it to calcium chloride, and as a result we got calcium metal because it got knocked out by the lithium, and now it's a loner. Lithium was more competitive than it, and now the lithium is happy in this compound and it is hanging out with chloride, and the calcium's off by itself. So summary of what we did: we looked at our element, we saw if it was higher on the list. If it was, we had it take the place of the cation in that compound, and then we balanced accordingly. So let's look at a couple more examples of that. Okay, so let's look again. Let's say we have strontium, and we're going to add that to nickel bromide. And this is nickel 3, so the charge on that nickel is 3, so that we have 3 bromines there. That's not really going to affect us right now, but what we need to do is look on our activity chart and compare the location of strontium to the location of nickel. Because strontium, if it was to become an ion, it's going to be a cation, so it's going to compete with this nickel. We don't have to compare it with the bromide because they're on different categories. But let's go here and see where strontium is on our list. Okay, looking through there, there's strontium. And now let's go and compare to where our nickel is. So looking through to find nickel, and nickel's clear down here. So strontium is going to knock nickel out of this place here because it's higher on the chart. So draw our reaction sign there. The strontium is now going to take the place that the bromine was in. So we have strontium, and we have bromine. And now we have to look and see what the charges were on it. So strontium, we know, is in our alkaline earth metals group here. There's strontium, so it has a +2 charge, and bromine has a -1 charge, so we need 2 bromines to work out with that strontium there. And then left over then, we have our lonely nickel that got knocked out of this compound. It doesn't get to be with another element anymore, but it'll be happy over by itself here. It'll drop out of the compound. So strontium plus nickel 3 bromide gives us strontium bromide and solid nickel. Now if we were to go back and put in the descriptors here, this is a solid, this is going to be aqueous, then this is going to be aqueous, and here's a solid. Let's try another one. Say we have iodine, and that comes as a diatomic because it's one of our Hunkelbriefs. As we can see on our diatomic list, Hunkelbrief, there's iodine, so it comes like that, and it's going to try reacting with nickel bromide. So this time we're not going to compare our element here with the cation because it wouldn't become a cation, it's going to become an anion. So we're going to see if it can switch out with this bromine. So let's look here and see how iodine compares with bromine. There's iodine at the bottom of the list and bromine's right above it. Okay, so this is the first time we've seen this. If the iodine is not higher on the list than the thing it's trying to knock out, then nothing's going to happen. So there's going to be no reaction here. So we can just write that. There's going to be no reaction. Or we can just write an R for no reaction, so we can abbreviate it there and save some time. We are going to compare on the list. If it's higher, we replace it. We look at our charges, we make a compound based on that. If it's lower, then we are just going to say no reaction, because the thing that was already in the compound has a greater desire to be in the compound than the thing that's trying to come in, so we're not going to have anything happen. Let's look at one more example here. Let's say this time we have aluminum, and we're going to see if that reacts with copper sulfate. Aluminum and copper sulfate, and we'll see if that reacts. So the aluminum here, we're going to see if it displaces that copper, because that's a cation, So we're going to look on the list, look for aluminum. There's aluminum. Let's see where copper is. Copper is clear down here. So aluminum is indeed going to replace it. It's a more reactive metal. So we will look here and see how that works out. So the copper is going to be a loner now. So we'll write copper by itself, and it would be a solid at this point if we were keeping track of that. I'm not going to be as concerned with it right now. That'll be really important on the next type of reaction we have. So copper plus, so now we'll write aluminum and our anion, which is a polyatomic this time, so SO4, sulfate. And we'll look to see what the charges on each of those are. So aluminum, so we can see here, it's going to be a +3 charge. And then of course our sulfate ion, we look there for sulfate and it's -2. So +3 and -2, so we're going to have to balance that out. We'll need 3 of those to 2 of those to make it work. Okay, so there is our reactants. We have aluminum and copper sulfate, and that gives us solid copper, and aluminum sulfate is our products. So that's basically all there is to do on these type of reactions. If it's a cation, you compare it to the cation. If it's an anion, you compare it to the anion, and then you just look and see if it's higher on the list. If it is indeed higher, then you can switch it out, and you have a new product that's going to form, and if it's not higher, then you're stuck the way you are, and nothing can happen, so you just write no reaction. Okay, so just to see and make sure that you got it here, here's one more example. I'm going to write it down, and then you should pause the video and see if you're able to do it on your own, and then I'll give you the answer here to see if you were able to get it. So I will say, let's say we have fluorine here, and we're going to try to react that with nickel bromide, nickel 3 bromide. So nickel 3 bromide, the nickel in this case has a +3 charge. So we're going to see if that reacts. So go ahead and pause the video at this point and see if you can get the answer to it, and then we'll pick up here in a moment and see what you got. Okay, first of all, we're going to compare fluorine with bromine because we're comparing an anion to an anion. So let's look here and see. Fluorine is at the top and there's bromine, so fluorine is indeed more reactive. Fluorine's going to kick this bromine out of that spot and take it. First of all, this diatomic here is not going to affect what we are in our resulting compound. That's just going to help us when we're balancing. So when we look here, we have nickel, and that's going to be combined with our fluorine. Now, we have to keep the same charge that the nickel had in the compound it was already in. So in this case, this was nickel 3, so we have to keep nickel 3 down here. So this nickel is going to have a +3 charge, and of course fluorine always has -1. So we are going to need 3 of these fluorines to balance out with that nickel, just like we had with our bromines there. So we have NiF3 for our resulting compound, and then we are going to have bromine sitting out by itself. Also, don't forget at this point, this bromine is a Hunkelbrief as well, so that's also going to need to be diatomic in our product. So whenever we have a product, if any of our products are a Hunkelbrief, we always have to look at it and see if it's diatomic, and if so, make it like that, which of course will change our balancing. Now at this point you would need to go back and balance it to make sure everything balances. It does not balance at this point. You will have to do something about this 3 and this 2, but of course you can balance on your own at this point, so I'm going to go ahead and stop the video and I'll get you a chance to work on your assignment here. So for your assignment, on page 20 in your packet, this is actually a combination between single displacement and another type of reaction called double displacement, which we haven't covered yet. We'll get to that later. So on this worksheet here, you're going to go through and see which ones on it are single displacement. So for instance, this first one here, we have an element, we have a compound, so this is going to be single displacement. This next one, we have 2 compounds, so we haven't seen how to do that yet. That's going to end up being double displacement, so we'll get to that later. For right now, just do the ones that are single displacement. So look through, and every time you see an element and a compound, do that one. If it's 2 compounds, ignore it for right now.